Hello, Ertin Çünker here with you today again. Today I'll be talking about data monitoring and data matching. It's going to be a relatively simple and easy exercise, yet it's powerful to show you how you handle data in Grasshopper. And I think it's going to be useful in the next steps or in the next tutorials or in your personal tasks or projects. So let's dive into it. Let me share my screen with you and let's start. So as you know, this is my Rhino screen, Grasshopper screen, and so on and so forth. So let's imagine a scenario in which we are trying to create sort of a surface in between two, I don't know, lines. Yeah, let me draw a line. Maybe just rotate it a bit. And let me draw another line. And let me rotate it as well. And let's think that we are going to create a surface in between these two uh, lines. It's relatively easy task, right? You can easily loft these two lines in Rhino and then it will be perfectly created. But let's imagine another scenario in which we are trying to create sort of a line network between these two lines. And how would we do that? And while I'll be going through this exercise, I'll be also mentioning quite important things related to data management, list management, in other words. So in order to proceed with these two lines, what I need to do, obviously, I need to either come under params, geometry, and put my curve in. If I right click to my curve and then say set one curve, and if I double click to my canvas and if I type curve, I will see my curve and set one curve, and I'll put my curve here. So as you know, or at the beginning, as I told you, the aim is to create line networking between two lines, right? Let's say these are some structural lines, maybe beams, maybe some other load-bearing elements, and we'll sort of knit in between these two. So what I would be needing in order to create something as such, I'll probably need to divide these lines, right? Or I need to divide sort of within a logic to these curves so that I can create these lines in between. And as you see, I'm just drawing now sort of a freestyle, and we are looking for something similar to this, but obviously this is a bit off because I just sketch it on top of these lines. So this is my first line. Let's say this is my second line, and what I need to do, as I did before, I need to have some points on it. I have to have some points on this one and this one, and then connect those points, right? So in order to proceed, or in order to do so, under the curve menu, I'll be going to analysis, and then what you'll be seeing here is divide curve. If I'm not mistaken, maybe it's not here. Let me see. Oh, it's under division, sorry. Divide curve. I come over to divide curve. I divide this curve, and obviously what you see here, there are three inputs. The first input is the curve. The second one is the count. Count is how many points you want to have on this curve. So let's say 15. And if I pull out 15, you see I have 15 points here. Okay, and 21. And kinks are like if you want to split segments at kinks, it's false. If you make this true, you will have kinks at each point. So what we are going to do next is we are going to do the same thing for the other curve. And like, let's say, let's divide this into 50. All right. So one thing quite crucial here, if I wanted to create sort of a regulated or like proportionally working or proportionally well working kind of a roof structure or like these line network, I need to be careful about how many points or how many or like what kind of or how many points again I need to have on each and every curve. So I'm going to have the points here, but one thing to consider, really consider here, is to see when I hover over to each and every output of the components, what I see is it's giving me the number of data that this output contains. So in this case, it has division points, and if you look carefully, you will see that 22 locally defined values. And all the numeric values that you can see on the screen is about the coordinates, XYZ coordinates. The same goes with the tangents, the same goes with the parameters, okay? And again, the same for here, and we see 16. One thing you need to a bit careful with Grasshopper, if I put 21 count, or if I put 21 as my count to create points on the curve, it will create 22 because 0 is also a number in Grasshopper. So if I divide this into 21, I will have 22 points, right? If I divide one curve into 1, I will have 2 points, right? That kind of stuff. So this is something you need to be careful, okay? And if I want to create a line in between these two, what I need to do is I can come over here and then say line, right? And if I connect this here, start point and end point. What I'm seeing here, if I look closely, this part looks working quite well, but from this point on, it gets a bit weird, right? Why it gets weird? Because this curve is divided into 15 pieces or 16 points, and this one is divided into 22 points. And that's why when the count of points hits 15 or 16 here, it will start to connect every single remaining point from this curve onto the last one of it. So how I can visualize, how I can create a visual of this to you to show you better. So now we are trying to monitor the data, right? So if I type here panel, panel is a very useful component in Grasshopper. It shows the data inside of the output that we are using. So we look at the points now, we see coordinates, and we see again 22 points, right? Not 21, 22, because we, as you remember, we include 0. And if I double click and create another panel, what we see here is this again. But how many we have? This time we have 16. So when we see this, we immediately need to understand, unless we have a specific reason to proceed, so we have to detect this. And even now in my project, the main problems that I face is caused by this data management. Even if it's tree, even if it's list, even if it's whatsoever, if they don't match, you will have some problems. You may not see them at the very beginning of the occurrence of the problem, but as you proceed, they will follow through. So it's really important to keep your definitions in a way that your data is matching the way that you want them to match, okay? Rather than relying on the results that you see on the screen. So in order to see this, what I can do, if I go to display and underneath preview, vector, what I'll be seeing is something called point list. What point list does is basically takes out the information on the outputs of the components and show us some numeric values related to those. Obviously, we cannot see them because we are seeing the points now. And if I right click to this component and if I say preview off, now I don't see any points, okay? And if I do the same for this one, I don't see any points here. So what I'm seeing here is it starts with 0, 1, 2, 3, blah, blah. It comes to 21, right? So what this does is basically listing the points in a way that we can follow which is connecting to the which one. So if I increase the size, let's say 2.5, just to see it a bit better. Oh, it's even worse. So if I put 50, maybe. Okay, maybe 100. Yeah, 100 works well. So what I'm seeing here, and if I do the same thing for this guy here, maybe I can do something like this just to make sure that our definition is clean and tidy. And if I Control C and Control V this, what it does is copy and paste it. I put this in. Now, what I'm seeing here is, as I described at the beginning, you see, it starts with like 0 connects to 0, 1 to 1, and then after the 15 point of this one, this curve, every single curve or every single point after 15 is connected to the 15 because we are not creating or we are not telling it to do something else, or we are not controlling our data in a way that we want them to correspond to one another, right? And if I decrease the number of this count, this time it works the other way around. So every single point after 10th is going to connect to the 10th one, right? So this may be the problem, or this may be a potential problem in your future projects or future tasks. So in order to visualize or in order to see what is happening, you can use this point list component here, point list component here. And obviously, if we want to make things work here, what we need to do is we need to use the same amount of divisions. Okay, let's say 15. And what we are going to see is we are, oops, not for the kings, sorry. And right click to this, display this, sorry, disconnect, and I disconnected it. And we now have the same amount of points. And what I can do here is I can create some groups to make my definition work in a bit more like in a bit cleaner way. So if you, by the way, select components from left to the right by clicking left mouse button, you select them all. Right click, group, you automatically group them. And you can do the same for this one. And what you can also do, right click to your group and you can change the color of your group, okay? And what I really like to do is usually pull out a scribble, meaning you can put a text and then say number of or point list monitoring. And if I right click, add to group, now I know when I open this script up, I pulled out this auto shelf, I can easily follow what I did. And I can connect this to this one as well. And what I can do is add to group. And I can do the same for this, like creating the group, pull out the scribble, dividing curve, I can put in, right click to here, I can add this to group, and the same thing here as well, add to group, but this time let's make the color to red to match these. And what I can do is I can pull this up, pull this down, and if I say loft now, you may know loft takes the curves and create a surface in between. And obviously, if I scale this line, like let's say scale 1D, we see it changes. If I rotate this, it changes. This is a basic, like a really simple Rhino-based parametric model, but it's really important and crucial to always follow or always monitor your data. Make sure they're matching so that you don't see or you won't see problems in the next steps of your Grasshopper script. And last but not least, let's create a group for this, pull out a scribble again, and then say network lines. Add to group, maybe change the color to, I don't know, like something like this, copy this and paste it, and surface, and then put this as another group, and then obviously we can make this to another color. So you can access all this. Now I can stop my screen share. So you can access these working files in the link in the description below. And if you like this video, please hit like. If you haven't checked the previous videos related to parametric modeling, I highly recommend you check them. And if you haven't yet, please subscribe. See you around.